Right. Good afternoon, good morning, everyone. Thank you for being here today. Once again, we are happy to see you here. We are happy to have you come and learn with us today. And I have some special people here in the studio with me today. You can see someone already smiling. I want to tap into the anointing of data science. I'll just move to the next slide. So we have these great personalities with us. They are directly from Microsoft, and they want to just share with us from their wealth of experience. So just relax and enjoy this session. So Bethany, please, are you ready for us? Are you ready to download and?
Yeah.
All right, so you can take it away. You can share your screen, right? I can pull this down.
Yeah.
Is that fine? So, audience, thank you once again for joining. We just want to go straight into it because we have a lot of things to do. So, Bethany, you can take it away.
Okay. Thank you so much. Thank you for the invite. I'm Bethany Jepchumba. I work here at Microsoft as a cloud advocate, and my focus is AI, data science, and machine learning. So everything around AI and machine learning is a passion of mine. Most importantly, I love Python. So I would, in my data science and AI journey, I would code in Python and then explore different tools such as Azure Open AI Service, the Azure Cognitive Services, and today we'll be exploring Microsoft Fabric. So I'll be sharing with you how you can start your data science journey in Microsoft Fabric. And a follow up in that is will be focused on, let me say, I love teaching and I love giving people or audiences that I teach something to walk away with. So in this session, I'll be referencing two learn modules. That is the one on data science and getting started with data science in Microsoft Fabric and getting started with Lakehouse in Microsoft Fabric. So I've pasted those two links in the chat and you can get started, or once the session is over you can continue and follow up from there. I'll be doing a demo to showcase all this, so I'll also share my GitHub demo so that you can go ahead and get started with it. So in this session, I am guessing that you're really familiar with like the basic principles of machine learning. You're familiar with the basic Python syntax, and I will be guiding you first in understanding the data science process, because it does not change. A change of tool does not mean you change the entire data science process. Then we'll go into a bit on Microsoft Fabric, dive into notebooks, Lakehouse, experiments, and models. And then after we do that, I'll share with you something around ML flow, guide you on how you can now connect the two and track your model, track your experiments. And yeah, at the end of the day, you'll be able to do the end-to-end data science process on your own. So the agenda is the same as the learning objectives, so I'll just go right ahead into the introduction. I'm pretty sure most of us are aware about data science, how it affects our lives, and if you're not, the simplest explanation I can give is data science allows you to identify the different patterns in our data and generate insights from large amounts of data. So if you have data, you might want to, let's say, for example, figure out how exactly is this data moving and what are the different patterns in this data and how can I use it for future use. So, for example, we normally have our budgets, right? So maybe you don't actively track your budget, but you might find yourself having you might find yourself in the point whereby you're losing money, but you don't know where your money is going. So you decide, okay, let me start by building a budget. And you can do a simple budget, let's say in Excel, and with that you can create something very beautiful with the data, because with Excel you can track, okay, this month I spent this amount of money, this is where my money went, and I got this amount of money, right? And then you can grow from there, from small data. Like you can just start from like analyzing your expenditure, and then grow from okay, analyzing your investments, and from there it gives you insights on like okay, so there's a prediction that probably next month you might still earn the same amount of money because probably you still have your job. And then you might get the insight that last month you spent extra going out, like you decided to splurge and you spent a lot of money going out. And that is your budget will tell you that extra was too much or too little, or yeah, that's the right amount of extra. So next month when you're splurging, ensure you're splurging within this range and so on. And it helps you when you create something like a budget, it guides you in terms of you now have the freedom to do things without thinking. So you just log into your Excel file and you check, okay, I have this amount of money. This is the amount of money I'm supposed to be spending on ABCD, and this is where I've spent it, and so on, right? So that's data science, basically helping you identify the different patterns in your data and generating insights. But in Fabric, the main audience, the main target is the big data that you might have. For example, you might be having a lot of company data in terms of marketing has this bulk of people, and you need to analyze which person should have like this marketing message target to them versus this other thing. And in Microsoft Fabric, you'll be able to train a machine learning model using notebooks and track them with experiments. So that's the fun bit about this whole session. So you learn how to go into Microsoft Fabric as a data scientist and be able to do your experiments, train your models, and see how you can do all that from start to finish. If you're new to data science, let me give you small insight on how data scientists work. So, as I mentioned, with data science, you get insights from whatever data you have, whether a very small data set like your budget or large company data sets, which are most of the time complex. So you get to look into your data, train a machine learning model, and get predictions from there. So, for example, this is how machine learning models work. So, for example, you might, as I mentioned, you might have like you might have your marketing team, and they want to divide people into different groups, right? So that they know this message is going to this person, probably because they're this age and there's a likelihood they're still in school, or because they're this age and they're this gender, and there's a likelihood women say something important to them. So that's one bit of machine learning, that's classification, whereby you're able to predict like the categorical value. So you're able to predict which category this person belongs in, and then you're able to now share the message to them based on their category. And then there's regression. Regression now might come in the budget. So you've created your budget and you want to predict like the value, let's say, how much will my bills cost next month based on what I've done in the past. And then, of course, there's also forecasting. Forecasting is time series data, same with your budget, but in a company setup might be something like your sales. So you can be able to predict what your future sales might look like, what you hope to gain like 10 years from now, 5 years from now. And you can also identify patterns like probably for us, July is a cold season. So if your business deals with something like wool and warm clothes, you might see a peak depending on like the different seasons. So it can also help you prepare your products and prepare like when the demand is high, prepare a high supply, and then when demand is low, you can reduce your supply so that you don't oversupply and also you don't get like wastage and so on. So that's basically the different machine learning models. This is just like an overview of them, not necessarily like all of them, because machine learning is wide, but there are two main bits of machine learning models. There's the unsupervised and then the supervised. Unsupervised is whereby data is learning on its own. You don't give it like a target of, okay, this person belongs to this group. Just tell the data, okay, try and group for me these people. So that's, for example, clustering. And then there's supervised, whereby, for example, we're trying to predict a numerical value. You, from your budget, you already have like your bills. So someone might know, okay, this amount will go to your bills, this amount will go to like your family and friends and so on. So you can be able to predict that without necessarily, your model can be able to predict that and help you predict in future and so on and so forth. Okay, another data science bit about the process. So this is how now I'll structure the demo and the presentation. So in data science, number one, the first thing is you first define what exactly you're solving. So for our demo today, it will be a sentiment analysis project, and we're using the Yelp dataset. So the problem is trying to understand the reviews, whether reviews are positive or reviews are negative, right? And then the second bit is now getting your data. The data, I wouldn't scrape it from anywhere. I'll just get the data from Kaggle, but the data is also on the GitHub repository. So you can just go get the data in the GitHub repository. But then since we're using Microsoft Fabric, that means we have to bring our data into Microsoft Fabric, right? That will be the second step. And then after that, we prepare our data, we explore our data, check if there's any missing data, if there's something we need to fix. And after that, we go to the fun part, which is now training our model and using our model to make predictions. So first and foremost, we start with data, so getting our data. This is the infrastructure of Microsoft Fabric. So we have OneLake, which is where everything is stored and where Lakehouse is now connected. So the main bit we'll be doing is data science. We won't cover the rest. I'm pretty sure the other speakers will cover things like data engineering, data factory, warehousing, real-time analytics, Power BI, and data activator. And I'm also pretty sure, since this is a data community, you've heard a lot about Power BI. So the main thing I'll cover is one Lakehouse, which is in OneLake, and then I'll cover Synapse Data Science. Okay, so as I said, the first bit is Lakehouse. So Lakehouse is built on top of OneLake, and it's a scalable storage layer and uses Apache Spark and SQL Compute for big data processing. A Lakehouse technically is a unified platform, so it contains one, storage, flexible and scalable storage of a data lake. And then two, you can also be able to query and analyze your data there. So it's like, let's say, multifaceted in terms of like you can be able to, one, store your data, and two, you can be able to query your data. So for example, imagine this, that your company has been using a data warehouse to store structured data. So it stores data, for example, the different transactions, the inventory, the orders, customer information, and so on. And you've also collected data, for example, from social media. You've been able to scrape Twitter or scrape the new one, Threads or something of that sort. And you've been able to get data from social media, and you can tell what other people are feeling about your company. And then there's the devs who are working on like the websites, so they can be able to track data in terms of like the clicks, where people visiting, where people going, how are the sales, and so on. So you have all these things, and you want to put them together in one place. So your company might want to like be able to have all this in one place to improve the decision making capabilities, and also they might be able to need to analyze the data. And you've seen the data is from everywhere. So there's like invoices, transactions on this side, there's social media, then there's the website, and you want all of this in one place. Microsoft Fabric can do that. and it can do that through Lakehouse. So a Lakehouse is generally a database built on top of a data lake, and Lakehouse uses Delta format tables. So a few features of the Lakehouse is Lakehouse uses Spark and SQL engines to process large-scale data and support machine learning for predictive modeling and analytics. So currently, there's no GPUs provisioned on Microsoft Fabric. It's a feature that probably will come up in a few, I'm not sure. But currently, we have Spark and SQL engines that can be able to help you support you big machine learning and predictive model analytics. So the other bit is around the data format. So the format is the schema is on read format, which means that you can define the schema as needed. You don't have like to have a predefined schema. So if, for example, you have data from social media and transactions, you can be able to read all of them without really necessarily having them in a structured format. And then it also supports ACID, that is atomicity, consistency, isolation, and durability, whereby your data will continuously be able, you can be able to access your data consistently. And also it also promotes your data integrity. And then the last one is Lakehouse is useful in terms of if you have a data scientist, a data engineer, and a data analyst all in the same team, they can be able to access and use your data regardless of where they are, right? And so I will go ahead and create a Lakehouse, a new one, so that we can start working on it. And I'm not sure which tier I'm on, but you can create using a premium tier. So I'm in Lakehouse. I'm in my workspace and I want to create a lakehouse. So to create a lakehouse, I'll go to data engineering, and under data engineering is whereby I'll get the lakehouse option. So if you want to create like your data pipelines, your Spark jobs and so on, you can create all of them in data engineering. But the only thing I'll be doing in data engineering is creating a lakehouse. So I think this community, no, let me go with section that we're doing, which is data fluence. So I'll go with data fluence and name my lakehouse data fluence. And I'll go ahead and create a new lakehouse. That's simple. So with a lakehouse, as it creates, let me go to the next slide. So the lakehouse, you can be able to store data in forms of files or tables. And the other thing is it also has an SQL endpoint, which you can connect and query the different data that you have. And by default, you also have like the data set that's there. So this is what you create when you launch a new lakehouse. And from the lakehouse, the next bit is you might want to do is like import your data. And to import our data, the same as it is in most, I think even in Power BI, it has the same feature. You can just click on get data, and these are the different data formats that we have. So one, you can upload local files or folders to your lakehouse. Next, you can create a new data pipeline. So data factory pipelines, you can copy data and orchestrate the different processes. For example, how they can be able to load the data. For example, you want to get files, and then how those files translated to tables and so on. And then we have data flows. Data flows helps you import and transform your data using Power Query Online. And then the last one is shortcuts. So shortcuts is, for example, if you want to link it with, let's say I want to link it with Azure Data Lake ADLS, or I want to link it with Amazon or something of that sort, you can be able to do that. So that's how to import data into a lakehouse. For me today, I'll just upload the file as I have it locally. I'll go ahead and upload the file. You can get the file in the GitHub repository. So let's wait. Oh yeah, here it is. So go to upload files, click on it, and then the file is under the sentiment analysis, the GitHub repo, and then the file will be the CSV file. I'll go ahead and open the file and upload. And that's it. You've uploaded your data in Lakehouse. You can, in case you have like your data elsewhere, you can go ahead and try and upload using the different types and so on and experiment with them. But I think this is for us today. And once the data is uploaded, I'll come to files and I'll find my data here. Right? So I can preview my Yelp CSV dataset. And as I mentioned, you also have the SQL endpoint. So if you want to query the data, you can do so using the SQL data point. I mean, the SQL endpoint, sorry. So how do you like go ahead and once your data is loaded, how do you go ahead and, for example, transform and explore your data? So number one, for us, we use the first option, that is Apache Spark, whereby one, you can just create a notebook and interact as a data scientist, as you do with other tools, whether you're using Colab, whether you're using Anaconda or VS Code, you'll use notebooks, and that's how we do it here. So you'll use notebooks to be able to interact with our coding, with our data. The other option is using the SQL endpoint, which I just showed you there. And you can run transact SQL statements to query, filter, aggregate, and also explore the different data that you have in Lakehouse tables. And then there's data flows, and lastly, data pipelines. So that's the different ways you can explore your data in a Lakehouse. As I said, for us, we're going to use the notebooks option. So let me go back. So this is how our data, the preview of our data, this is how it looks. So for example, this is text that the text replies that people are giving. So you can see, do yourself and get a Bloody Mary. It was phenomenal, simply the best I've ever had. This is like a very positive review. And then this is negative because they're saying, well, everything, or neutral, well, everything. The menu looks excellent. I had a white truffle. It came with 2 pieces. It was the best toast I've ever had. So that's positive. So yeah, so we have, so our data contains like the business ID, the date, review ID, stars, the text, the type, the user ID, and then values of like, it was data cool, was the text, was the review cool, useful, funny. Yeah, so that's our data. And as I've mentioned, for us, we'll just create a new notebook and interact with our data there. So to create a new notebook, just do as they've done. I hope you saw that. So let me go back to Lakehouse and then show you again. So open that notebook and then a new notebook, and you'll create your notebook, and your notebook will be created. And then I think the first thing you might want to do is probably rename your notebook. So click on the notebook and I'll name it data fluence. Oh, sorry, data fluence. Okay. So before I continue, so I've already imported the data. So the next step is now we go into our code. Before I continue, I have a question. So this is the first question, and it's relatively interesting one. If you've been following through what I've just been guiding you on, you probably might have an answer on this. So what exactly is Microsoft Fabric Lakehouse? Is it a relational database based on the Microsoft SQL Server database engine? Is it B, a hierarchy of folders and files in Azure Data Lake Storage Generation 2? Or is it C, an analytical store that combines the file storage flexibility of a data lake with the SQL-based query capabilities of a data warehouse? So let me give you a minute to reply to that as I catch my breath. What is a Microsoft Fabric Lakehouse? You can just type in the chat whether it's A, B, or C. I'll continue after I receive at least one answer so that I know I have people who are listening to me. No one. A, B, or C. You're muted.
Yes, people are listening. Some people are following, so I'm also waiting for their responses. But just
Yes.
know that people are following. We have some people. Some people drop on WhatsApp. We need you to drop.
On the chat. We can't see on the other
Need you to
side.
drop on YouTube on the chat, like reply. I've been dropping messages. You can use the link to go. Okay, good. Mukaila Adeshina said C. He said
Yeah.
C. So we
Let's
are
let's
waiting for
go.
others.
Let's wait for others.
People should not drop on WhatsApp. I receive another one on WhatsApp. Please drop this on YouTube. Please drop this on YouTube. I saw two C's on WhatsApp. I just saw notifications, but I need the message to come in
Let's have
here.
at least three people and then we continue.
All right.
Yeah.
Okay, I can see another C. That's two.
Two.
Yes.
Ah. I think that's enough. So yeah, the answer is C. So
Oh,
I'll let
I can see another one. C. Okay,
yeah.
Shakiruddin.
Okay. Thank you so much. So yes,
Yeah.
the answer is C. A lake house combines both the flexibility of a data lake, so it has like the storage where you can store your files, and then it also has the SQL-based query capabilities of a data warehouse. As I've mentioned, you have things like SQL endpoint, and you can also like add your notebooks and so on onto your Fabric Lakehouse. Okay, thank you for that. So I'll go into the next bit, which is now the data science bit. As I've mentioned, in data science, we have three main things. That's notebooks, experiments, and models. And I'll start with notebooks. With notebooks, whichever tool as a data scientist you're using, you'll definitely find yourself using a notebook. And I've already created the first notebook. So I think the first thing I'll do is import, let me just use the first bit. So the first thing I want to do is import our data. So I'll import, let me make it well zoomed in. I'll import pandas as PD, and then you might find it a bit hard to import your data, right? So you might be wondering, is there an easier way? How easy is it to import data here? So I can go to my files, select on Yelp CSV, click on it, and ask them to load my data. And since I'm using Python, I'll ask them to load it in pandas, and they'll give me the code. This is just for loading your data. So it doesn't, for now, the capabilities are limited to just importing your data. But then you can be able to do that without necessarily trying and figuring out, okay, which code am I supposed to be using to import my data and so on. So that's the first step, importing our data. You've seen the link, it links to the Lakehouse default and then files, and then under files, it links us to our file, that's Yelp CSV. And then it will take, of course, a second to display our file, our data. Let's give it a second. Okay, so our data is loaded. As you can see, it has like the business ID, which I don't think is necessary for us. The date also not necessary. The review ID not necessary. But I think where we'll focus on is the stars. So stars is like the rating someone gave after they gave the review. Then the text is the review type. I guess majority of the types are reviews. So we'll also don't need this column. We also don't need the user ID. We might need to know sentiments from the text, maybe things like, was it cool, was it useful, was it funny, and so on, to be able to help us now with the sentiments. For example, if it was a 5 and it was cool and useful, and it was a 5, that means there's a high probability it was, let's say, a good review. But then there's a problem. There's a 5 also with like 0 and a funny, useful, and cool. So we'll have to dig into our data to figure out, are these are these all columns really necessary? Do we need to do all this? And so on and so forth. So first step I normally like doing is checking if we have any missing data. So I use df.info, which gives me an information of our data. And as you'll see from the output, all of them are null, all of them are, so we have objects and integers, and then we have at least 10,000 reviews. That's a good number for different reviews. And then we might want to add a different column, and this column might be useful, might not be useful, but this column, I'll give it the name text length, text. And why I'm adding this column is probably the length of the review we're getting, probably it might come and tell us whether it's positive or negative. So we just want to check the relation between that, right? So I'll add that. I'll add that new column, and the column definition is from the text, apply the length, and then give us the new column. So apply length, that's the length of the words. And then from there, I'll read the data set again. So df.head gives us like the first 5 values of our data, and you can be able to see, it gives us the business ID, the date, the review IDs, and the text length has been added. So yeah, you can see, for example, this is a 4 rating and it has 76. So text length, and then all these, the rest are 5, but then you can see they're varied, right? So we'll have to test and see if that's something that we'll need to use or not. Okay, so that's a bit about just looking at our data. The next, you might want to do visualization. So the first visualization I will try and do is df-describe. df-describe looks at the numerical values in our data and shares with us like the numerical metrics from them. So for example, stars, we have 5 stars. So stars, the minimum is 1, maximum is 5. And you can see the mean is 3. So majority, there's like a balance in our data and so on. And then same with cool, minimum is 0, maximum is 77. So the rating of cool is probably from 0 to 77. We also have useful, we have funny, we have text length. So our text length is the one that I've just created, and you can see the mean is 710. So that means majority of the text that we have lies, of the length of the text that we have lies between, let's say, 600 to 800 there, right? And then you have outliers, we have the maximum at 4,000, and then we have the minimum at 1 word. So probably someone just said, good, and that's it for the review. And then the next thing I'll want to do in visualization is visualize our word cloud for this. So first I'll install the word cloud library, word cloud library. And then once it installs, you're doing the same thing you'll do in your local data science tool. This is exactly what you'll do there. So to create a word cloud, I want to create a word cloud for 1-star reviews. So first I'll define the 1-star reviews. So the 1-star reviews are df into stars. The stars is equals to 1. Those are the 1-star reviews, right? And what next I'll do is doing the whole reviews, doing the text that I get from there, have them into like one long sentence or something of that sort. Join 1 star and then the text. And then from there, I'll go ahead and create now the word cloud. So from word cloud, import word cloud. Okay, and then 1 star underscore cloud, and then name it word cloud. Use the, use the word cloud library that I just imported. Then generate word cloud from the one star text. So, sorry, 1 star generate. Right, so from word cloud, creating the 1 star cloud, and then next I'll import matplotlib. Matplotlib. This is a visualization library. So matplotlib.pyplot from as PLT, and then now plot the graph. So plot.im show into 1 underscore star cloud, and then interpolation. I'll have it as bilinear. And then the last bit is the axis, so plot.axis, and then I have it as off. I hope I've done the right code. Let's run it and see. Yes. So this is our 1 star reviews, and you can see there's technically nothing negative here. Time, food, place, service, really, told, take, never. So never might be one big word there. Bad might also be another. Let's try with 5 stars. So this is 1 star. Let's try the same. So I'll just do the same code, change to 5. So I'll change the 1 to 5. Change that to 5. And then for here, I'll have them as 5. It's the same code. So just trying to see the difference between a 1 star and a 5 star review. So you can see the difference. So here the good was small. Here the good is big, like in terms of there's more people saying it was good. Then there's great. Then service, food, place has been repeated in both. Then you can see there's love, there's right. So I can say there's some people who are saying the review is good and you can be able to check on it and so on. Okay, so that's visualization. That's technically you're able to now view your data and you can be able to tell, okay, this is what was happening here and so on. And then now we go into like preparing our data for modeling. And before I decide I want to train my data, I want to ensure I've looked at everything. So first, we've said our data contains 5 different stars, 1 to 5. So I'll want to check in all these 5 stars, how is the data distributed? So I'll use value underscore count to check the distribution of our data. And you'll see the 5 star and 4 stars reviews are about 3,000, and then our 1 star review is just a little less below 1,000. So this means this might be something you might want to do. So this, I think this I'll leave as an assignment. So what you might want to do to make your data better is probably reduce the stars, reduce the 5 star to just 1,000, reduce the 4 stars to just 1,000, same to the 3 stars. So that you can have a bit of an equal data set. It's not very imbalanced, right? And then also you might realize training our data with both 1, 2, 3, 4, 5 might be a bit, our model might be a bit confused because the difference between 1 and 2 is very small, right? And our data is not that big, right? So I might also want to reduce the stars to either 1, 3, or 4, or 5, I mean. So 1 will be the negative reviews, 3 will be the neutral ones, and 5 will be the good reviews, right? Because the difference between 4 and 5 is probably negligible, and it might also be the same with 4 and 3, and 3 and 2, and 2 and 1. So that's what I'll do next. So back to my data set, and then I'll concatenate the different, I'll use concatenate to add the different values. So the first thing is our data set. So I'll add the 5 stars, 3 stars, 2 stars, 5, 3, and 1 only, right? To a new data set. So here the stars will be, we have stars. Oh, I've done a mistake. So data frame again, and then the stars will be equal to 5. That will be the first one. Oh, sorry. Sorry. So the stars will be equal to 5. That will be our first data frame. And then do the same for the others. I feel like I've made a mistake. Let me repeat this whole area again. So a data frame, and inside the data frame we have another data frame, and inside that we have the stars, and the stars are equal to 5, right? So that's the first one, and then we also do the same for the others. So the second one will be the stars are equal to 3, and then the last one will be the stars are equal to 1. So data frame will be equal to 1. And then our new data set will now contain stars that are only 1, 3, and 5. So if I go check the stars that we have, so stars, and then calculate the value counts, underscore counts, it will give me only 3, 4, and 5. I mean, 1, oh, error. Where is the error? First argument might be an data frame. Stars 3, 2. This is interesting. Okay, let me try and see what it will give me if I do df into stars equals to 5, and then df 5, so that it do not interfere with the current data frame, and then df underscore 5, and then into the stars, and equate this and find the value count of this value underscore count. Let me see what the error is. It's giving the same error. This is interesting, but I know what the error might be here. So let me add this too and check Whether the error is still there. Yep, series object has no variable, has no value, has no attribute value counts. This is interesting. Sorry, give me a second. So the stars goes to 5. Let me start from there first. Stars equals to 5, value count. Interesting. Stars is okay. I'll have to run my code again. Sorry for that. Let me run this cell again. Sorry for that. I'm wondering where my error is. Okay, as I wait to resolve that error. So the code here, the main objective of the code is to reduce our data set into only 5, 3, and 1 star reviews. And then once the reviews is done, we'll now go into creating, yeah, it's done. It's still giving the same errors. I'm wondering why it's giving an error on stars. Okay, this is the code, the value. And let me equate it to 1. See if it will still give me the same error. Series has no attribute value count. Okay, what the hell is DR5? Okay, let me see if it works. If this works, that means yeah. So this works. So I can just reuse this instead of doing the whole confused thing that I was working on. So I'll reuse the same code. That's the first one, second, and third. So I'll just replace the values to read 1, 3, and 5 and check if I can get the value counts. I'm not sure where exactly the code is going wrong. So let me just do df.head again and see if the code is okay. Yeah, the code is okay. So I'm not sure what exactly is happening. And it's filtered only 1, 2, and 3. Let me go back and do a second df.info to check if my code is okay. Okay, so yep, 5547. Yeah, that's I think the right number. So the next step will now, I would have wanted to create a data frame with just the stars, the text length, cool, useful, and funny. But I'm not technically going to use all that. But let's do that because the next thing I want to do is to remove the stop words. So if I remove each and every bit, unnecessary bit into our data frame, so I'll remain with just the rows and columns that we need. So, for example, I'll retain the text. I'll also retain the stars, of course. I'll retain the text length. I'll go ahead and also retain the metrics. That's cool, useful, and I'll also add funny here. So this, I will have created a new data frame. And what I want to do with this new data frame is I want to remove stop words from it and so on. Stop words are words like connecting words. So, for example, when you're speaking or you're giving a review, there's some words that might be found everywhere. So, English stop words might be things like he or she or something of that sort, because they do not add any value to our sentences. So to be able to remove the stop words, I'll need to install NLTK, which is a library. So pip install NLTK and then run that. And then from there, so after installing, I'll now go ahead and remove the stop words. So first I'll import a new library that's string, and I also import an LTK, the one that I've just downloaded, right? And then from there, from NLTK, I'll download the stop words. Also, you don't have to stop at just removing stop words. We also might need to go ahead and probably remove the punctuations and so on. So to do this, I'll create a new function. So text process will be the function name, and that's where the text will come in. And then from there, the first thing, as I've said, I might want to remove punctuation. So I'll add a comment here, remove punctuation, and then let's say no punctuation as a variable. And what I'll do is name the variable. So char for character in text, if character not in this will eliminate all the punctuations. So if the character is not in the string punctuation, that means I will come back here and join the different characters. So that's for like a single text, right? Join no punc. And then the second bit, as I've said, is the stop words. So from NLTK dot corpus import stop words and then once the stop words have been imported, I'll go ahead and also import a stemma. So for this, let me actually leave some of this for you, but no, let me just continue. So the other thing I can do is stem the words. So stemming the words is, for example, words like swimming come from the word swim, right? So no, swimming is not the best example. Playing, played, no. Yeah, playing. So playing comes from the word play. And play, you can make words like playing, played. I think those are the two words that I can say at the moment. So to remove the tense, the past, future, or continuous tense, you stem the words. So stemming the words playing will bring the word back to play. Stemming the word played will bring it back to play. So I'll also import stemma, porter, and then I'll define the stemma. That's porter stemma, and then next I'll now return. Okay, this function is not the best. Probably you can go ahead and try and simplify it, but I'm trying to ensure I have everything together in one place. So first I'll stem the word, and then after that, for word in non-punct, split. So, and then the next thing is if word is lower. So main reason for this is most words that are what are they called? Proper nouns. Yes, those ones. So proper nouns are like people's names and so on. So if a word is a proper noun, I don't think if like two is a proper noun, I don't think, or someone is called two, for example, they will have that in capital letters, right? So I don't think it would be wise to remove that and other stop words that you might be thinking of. So for word in lower, they're not in stop words. Words, and then define the language, in our case, English. So basically what I've done here is remove the punctuation, then added the stem, and then remove the stop words. And then the next bit is have this implemented in our data frame. And that's what I'll do is have that implemented in everything that's in text. So in the text data frame, I will want to apply all the changes. So dot apply, and then the function that I've just created, text underscore process, and that will be it. So we've now removed the stop words and our words. Sorry for that. I'm also a victim of punctuation. But yes, so we've gone ahead and removed our punctuation. And then I don't know if I want to do anything else. I think our text is now good. So I may not be able to go ahead and do no module named NLTK. Just installed NLTK. What? Oh, NTLK. Oh, I've made a mistake. Spelling is not my best. It's not my best. And then I've repeated the mistake. NLTK, NLTK. So yeah, I think that will work. So I've not gone ahead and done a lot. I've not gone ahead and done a lot of preprocessing. So you might also want to include like the text length, the cool, useful, fun. You might also want to include that in your oh, yes, spelling is not my best friend, and I've also misspelled that. So yeah, so you might go ahead and do things like find ways in which you can include like the text length, the column, the cool, useful, funny into your model, and find a way to be able to use them also. This is interesting. So it's telling me it's missing, but the word is in text. Let me try something. I'm wondering why exactly it's telling me it's missing the words. Okay, so after this, we'll be heading into the last step, which is now us going ahead and, yeah, the last step will be us going ahead and now training our model. So this is where Azure ML, the Fabric, Microsoft Fabrics comes in. So yeah, text is there. So I'm wondering why it's telling me it's missing the word. for character, not in string. This is interesting. Anyway, I'll figure out what the error is and fix that. But the next step is trying to now go ahead and train our model. And to train our model, the first thing is defining the variables. So the X is now what we're using to train, which is the text. And the Y is what we're predicting, which is the stars. So we're trying to predict the different stars in, like, what text will bring us what star, right? So that's defining our targets and variables, our targets and our inputs. And then the next thing is splitting our data into test and train. So the essence of splitting our data is to validate what we're training so that at the end of the day, we can be able to check and test if our model is accurate or it's not, and the accuracy level, and so on and so forth. So train tests underscore split. So that's what we import to split our data. And then I define the X train and then the X test. Oh, sorry. And then the X underscore test. And then the Y underscore train. Then the last variable we're doing is the Y test. So once you've been able to train your model, you can come back again and have it tested. So split it into the X, the Y, and then the test size. So test size is in percentage. So you can say like 3 or 30 or 20 or something of that sort. So I'll split it with a test size of 2. And then next is now training our model, right? So to train our model, I'll be using Knife Bias. It's not the best model out there, so I think that might also be an assignment from my end, trying for you to try and find the best model. So first, before I even import the model to train, I'll import Account Vectorizer. Account Vectorizer, the purpose of it is to convert our text into statistical values, because there's no way our machine learning model can be able to read text. So we're translating it into numerical values for that. And then we have the second thing I'll be importing is the TIDF transformer. It will do the same thing as the Account Vectorizer. So TF-ID, TF-IDF transformer. And then the last one is now I'll import our model. So from scikit-learn, I'll import Knife Bias. And then import it as multinomial. Okay. So, and then the next thing is defining, adding variables to what I've just imported. For example, I'll have the vectorizer, and the variable will be vectorizer, then the TF-IDF, and then the TF-IDF transformer, and then our model, which is the multinomial NB, which I'll give it Knife Bias, and then import it as multinomial NB. So that's just me giving all of them a variable. And then we can create a pipeline for this. So the next bit is importing a pipeline. So from scikit-learn, pipeline, import pipeline. And then I'll create a pipeline from our values. So the pipeline will have And the first thing will be the vectorizer. Vectorizer. And that I've already given it the name vectorizer, so that will remain the same. And then the second one will be the TF IDF, and then the value is still the same. And then the last one will be our model, which is naive Bayes, right? And the model name is NB. So this is the same way you'll do it in any other tool, but then the difference will come in when you'll need to use MLflow. So this is the training, right? So this is the data you need to train your model. And of course, the last bit in training a model is to fit. So I can do the pipeline fit, pipe.fit into our model, that is the x underscore train, comma, the y underscore train. And then probably you can make predictions and so on, right? So that's the main bit around training. It's the same, you will do the same in Fabric, but what you will need to add is MLflow. So MLflow will help you in setting your experiments and your models and so on. So this is now the Microsoft Fabric bit that is key. So first I'll do, so this is our pipeline. So you can see the count vectorizer, the TF IDF transformer, and multinomial and with the naive Bayes model. So we need to use MLflow to now record our experiments. So you can use create or set experiment. So for me, I'll use set experiment, set underscore experiment to set now to create our new experiment. So I'll name it data fluence, and then probably 23, then run that MLflow. And then with the MLflow, I'll need to add details. I'll need to now add the model and everything there, right? So the first thing will be the YPred. I haven't, no, actually I can do that. No, let me just continue from here. So one is the Y prediction, which will now be the pipeline dot predict. Now we're using our test data. So that will be the X underscore test, right? That's the first step. And then I'll also want to add metrics to our model. So I'll want to see how our model is performing. But before I add the metrics, I'll need to also import them. So for example, I'll do from sklearn dot metrics, I'll import the different metrics. So for example, the first metric will be the accuracy score, then the second one will be something like recall score, then precision, then score again. Then the third one will be, I think, F1 score, right? So all these are used to score a model and tell us the performance, right? And then I'll also need to define, like, okay, so for accuracy, what does accuracy stand for? So for example, accuracy will be accuracy underscore score. No, let me just define it as accuracy. So that will be accuracy score of the prediction. That's now Y underscore test versus Y underscore predict. And I'll do the same for all the metrics. So I'll do the same for precision, for recall, and so on. So for that, let me just copy the code here. And I've defined all the With this, I've defined all the variables that we need for our ML flow. So to start our ML flow run, I'll type with ML flow and just add start run, start underscore run as run. So this is now our experiment. So we are adding the first thing we're adding is the metrics. So mlflow.log underscore metrics. So the metrics will be, for example, accuracy that will be matched to the accuracies that I've already defined up there, so on and so forth. So we'll do the same thing for accuracy, you do the same thing for recall, precision, and F1. And then once you've logged the metrics, the next thing is logging the parameters. So the parameters will now include our model. Give me a second. Yeah, so the next thing is logging our parameters. So mlflow.log underscore parameters. Parameters. So our parameters are, have I defined them really? Not yet. So I'll need to define the parameters that I need. So the parameters will be for our vectorizer. Let me define them up here also. So for example, for our vectorizer, we need, so I got this from doing a grid search to get the best parameters for our model. So that's where the parameters are. And then the last bit you'll need to do is now, once you've logged the parameters, the next thing is now getting a model. So next, I'll log the model, and I'll call the model data once underscore model, and then this I'll call it data plus. And then that's it. So that's entirely it with ML flow. So once I run the ML flow, before it even runs, I'll need to show you the experiment. So this is, let me go back to, let me go back to let me go to data science from Fabric. And in data science, let me filter by experiment. No, it's not yet logged. Interesting. Let me check here has the experiment run? Attribute error. I'm not sure why I'm getting this error. Let me run it again. Okay, so I'm not sure why I'm getting this error. So to remedy the situation, because I think I'll be here for a longer period of time if I try and fix that. To remedy that, let me just go back to the model that I already created and guide you from there. So from this model, I went ahead and did, once I completed like the metrics, I didn't get the best performance in terms of like with naive bias. So I decided, let me add some parameters. So these parameters now help me with making the model a bit better. And I used grid search to help me find the best parameters. This was the best parameters that were picked. So I went ahead and computed the metrics and logged this into the ML flow. And once I logged it into the ML flow, I was able to get the run going. Once the run went, it ran for a few minutes. gave me the output, and I was able to check using MLflow. I was able to check now the metrics. So, what was the accuracy, what was the recall, and so on. Yeah, and then from there, I went ahead and did a bit around. Now I've gotten the metrics. So, can I use this model to test, for example, a new review? And it was able to predict a 5-star review. And once the review was completed, I also tried and did other things. For example, I checked the different runs. So, I think for the code to work, I have to run everything. So once I was able to complete now, like I was able to check the predicted sentiment, I was content with the model. I went ahead also and did like an experiment, did a run to tell me all the different experiments and give me the output. So it was able to tell me, okay, this was the first experiment we ran, this is your URI, and so on. This was the prediction. So, for example, it gives me the accuracy of 0.6, which is very low still, and so on. And let me go to the experiment that I did, that I got, so that you can be able to see the output in terms of now how does your model look like, and so on. So, second, I'm not sure why it's not running. Oh, interesting. Yeah. Okay, so this was the experiment that I ran, and you can see it gives me the metrics and everything that I was able to achieve. These are the different experiments that I ran. Of course, some failed, some were successful, and you can see all of them have like a model attached to them. So depending on how you customize your model, how you continue and build on top of it, you get better and better results as you go on, right? So I got a better result. So for example, the last one I did, I got an accuracy of 0.81. You can see from 0.6 to 0.81. That's actually a big improvement. So I decided I was content with this, and I went ahead and saved the run as a model. So I saved as an, let me save it as a new model. Data points, and then saved it. And from my model, I was able to get the different artifacts that I would need to now utilize it in an app. So once you are able to deploy your model, you get things like, I hope you can see from my screen. So you'll get things like the PKL file, you'll get a YAM file, you get the requirements. So to build this, what do you need? You get the different YAM files that you need to run it, right? It also gives you like the different versions of the model and so on. So I was able to download this version because I wanted to use it locally. I was able to download the model.pkl, and from there you can see in the repository that I just shared. Once I downloaded the model.pkl file, I added them to my app.file, which is it is this is a Flask. This is a Flask application. So I was able to add the PKL file here in the Flask application. That's a pickle file, and I was able to now create a function that can, if someone inputs like the review, it can be able to give them the reply from that, right? And then from there, I linked it to Azure Web Apps and I created the application. So from here, you can add your review and it will give you a reply. So for example, let me generate a new review. Generate a 5-star hotel review. So if I generate a 5-star hotel review and come here and paste it, you'll see it will give me the feedback, whether it's a 5-star or a 3 or 4 or so on. And this is a long one. Okay, so let me just paste it as it is. Control C, and then let's check the prediction. So it predicts this is a 5-star review. It also gives you prediction results. So I'm not sure why the errors are so persistent in this file, but probably I'll go back and check on it again. But from the repo, you'll be able to find everything step by step, and then you can be able to improve your model. So for example, this model has an accuracy of 81%. So how do you make it better? So for example, you can do things like, how do you include things like the text length, the rate of whether it's cool, useful, or funny. Then how do you do things like ensemble, using ensemble methods and so on to improve your model. So let me do a recap in terms of, I've taken you through, I think, the entirety of everything. So from the first thing is, so you can create an experiment from the UI, but I created an experiment using the AgileML flow. So you can either use create experiment or set experiment. That will work either way. And then with that, you've created an experiment in Microsoft Fabric. And then once you've created your experiment, using set experiments helps you to run, track your parameters, metrics, and everything. So it helps you with logging everything that you need to log. And then from there, once you already have, like, this is what I showed you, how your artifacts will look like. So you can track, for example, the models from here. You can also track the different versions of your model and so on. And then the other bit around ML flow is the different, what are the different things you do with ML flow. So for example, log params is logging the different parameters, input parameters for your model. The second one is metrics. So if you want to add the different metrics, as I said, if you want to track like accuracy, F1 score, precision score, and so on. And then also things like artifacts and models, right? So the last bit is printing experiment. So I think I showcased this. So first, printing your experiment will get you like an output of what your experiment contains, and then the search runs will now give you the output of what each and every experiment output was. So those are the two. And then the last bit is the summary. So I created, I don't think we'll be able to go through the knowledge check because of time, but I created a visualization that summarizes everything that you need. So the first thing is a summary of everything that we've covered today. So the first thing you need to do is ingest your data to the lakehouse. And as I mentioned, the lakehouse is multifaceted in terms of it contains one, a location where you can store your data, and two, you can be able to do things like query your data and so on. And then the second bit is cleaning your data. So I didn't talk about Data Wrangler or SMP because of time. I didn't think I'll be able to cover that. And then the third bit is ML flow, which is, I think, the most important bit of the whole presentation. So using ML flow to create artifacts like your experiments, and then running your models, being able to track them, and so on. And then the last part is, because I know this is a data Power BI, it's a data community. That means you've used Power BI. So you can be able to visualize the predictions in Power BI. So I think, as I said, I like teaching. That means I won't give you everything that you need, but I'll also leave you with assignments or like thought pieces. So for example, you can go back to the data and see your predictions and see how you can visualize your predictions from the data. So that's something I'll also want to improve. So, for example, from the from the repo, you can see that I've done things like I've used grid search to now improve the models. I've also used other models such as SVM, support vector machines. And then I've also tried doing things like ensemble models, so using random forest. And then the next bit was me trying to use NLP. So that's the next bit I'll be doing. So using NLP. And then from there, I'll go ahead and visualize in Power BI. So you can also do the same with the model. Try and also use things like Data Wrangler and SMP and see if you can improve the model. But I think that's it from my end. I've already shared the resources on there. It was shared when the session began. So you can just get that from the session. And yeah, I think that will be it from my end. Um, yeah.
Um, this is this a dissertation, like a PhD load down? Because what you did, sincerely, it's too much. Is loaded. So thank you so much for this.
No
So there is
worries.
a question for you.
Yeah.
The question says, how did you publish the model for use on the web interface?
Let me go back to the code. Um, so this is the code. So as I said, I've used a lot of HTML, I mean ML flow. So the first bit was in technically the main difference of Azure Fabric and every other thing is with ML flow in terms of one you set up your experiment, and then from the experiment you now run your experiment. So for example, you train your model here, right? So then from there you go ahead, add things like the metrics you want to track, the parameters you want to include, and then export your model. So for this, since I was using grid search, I exported the best model in grid search. And then once it's done, I registered my model on Azure. I registered my model directly from the code. And where you can find all this is in experiments. So if you go to once you're done with your project, if you go to experiments, you'll be able to see something like this. So this is the Yelp model that we did, and you get all the requirements, all the details you need about the model. And one of the main thing I normally use is a pickle file. So in future, I'm going to try and do things like how do I deploy using like an API or something of that sort. But for me today, I just used a pickle file. So using a pickle file, you're able to download that. I downloaded that, went to VS Code or Code Spaces, added the pickle file, so it's here. And in my app.py, that's my Flask application, I was able to import that and use that to now detect sentiments. Yeah, basically that's it. So that's how I was able to now go ahead and publish the model. So to like reuse the model. But I think there's a better way to do this. So as I said, I'm a teacher, but I also am still learning. So at the end of the day, that was the easiest way to deploy. So I'll go ahead next and do something more interesting, like see if I can publish an API and have it consumed without doing the manual process of a pickle file. Yeah, and I believe it's possible. So probably I might need to use HTML or something, but yeah, once I do that, I'll also share that.
Thank you so much. I'm sure that you've answered the person. Your session uh, was fantastic.
Thank
And
you. Thank you.
I'm sure everyone relaxed. There was no pressure, so we're looking at it. Of course, the document you shared earlier has been shared with everyone so that they
Yeah.
can follow through with the class. So thank you so very much. On behalf
Yeah.
of Niger Data Platform, we say a big thank you for your time, for the resources you've shared with us. We are not taking you, not your time for granted. We say
No
thank you
problem.
so very much. Everyone, I'm sure that you are all saying thank you to Bethany. So I'm helping you to say that on your behalf. So this is just to let you know that our next session is coming up um, the next Saturday. So just so you know. And also don't forget, I've dropped the feedback form in the comment section. Please, your feedback is very important to us so that we can continue to improve. I mean, continue to ensure that it gets better. So I would want to appreciate everyone that has been with us from the beginning till now, and of course, maybe for other people, maybe because of internet, you are not able to be here. So you know that we appreciate your time, and it is nice having you here once again, Bethany. I hope that I need to come. I need to come to Kenya and get all this and many more from you. So thank you so
Thank
much.
you.
So
Thank
on this
you.
note, oh, Bethany, do you have any other thing? If there are other questions, please you can drop. But of course, I believe she has done due diligence to all of these and many more that we have not asked for. So please, once again, don't forget to drop your feedback and see you next week. On this note, I want to say love you and bye. See you once again. All right. Bye.